17. For a geometric series, S5 is equal to 121 over 9, and S6 is equal to 364 over 9. It says find the first three terms of the series and determine the general equation for the series. So first of all, what I've done is we've been given these two terms, and we really need to find A and R. So I've set up a system of equations where we express S with A and R, and we've expressed S5 in green and S6 in red. And we're going to solve this as a system of equations. And what we're going to do is we're going to do this by substitution. So what I'm going to do is I've got two variables. It's going to be way easier to substitute for A. So I'm going to isolate A and I'm going to substitute it into the other one. So I'm going to make A equal to 121 R minus 1 over 9 times R to the power 5 minus 1. And then what I'm going to do is I'm going to take that A and I'm going to substitute it into equation 2, which I've expressed with A's and R's as well. So I'm going to start with the A value here. So I'm going to substitute A as 121 over 9 R minus 1 over R5 minus 1. Keep that in factors. And I'm going to substitute that in for A here. So I'm going to end up with R to 6 minus 1 in the numerator and R minus 1 in the denominator. Okay, and again, what I've done is I've replaced that A with the A that I solved for in green. And this is all equal to 364 over 9. Now I'm going to simplify this before I start messing around with it. So there's common factors of R minus 1 here. So we have a restriction of R is not equal to 1. I should really write that down. So R not equal to 1. And then I'm going to cancel out some common factors here as well. 9 and 9. And then I'm just going to move these terms to the numerator. So I'm going to end up with 121 on the left-hand side, R6 minus 1 equals 364 times R5 minus 1 on the right-hand side. So simplifying this out, I get 161 R6 minus 121 is equal to 364 R to the power 5 minus 364. And then since this is a polynomial equation, I'm going to make this equal to 0. And noticing that this polynomial equation is a degree 6 equation, and it's not really, we can't really simplify it somehow. What we're going to do is we're going to solve this by graphing. So I'm just going to add 364 to both sides. I get positive 243, and that's equal to 0. So there's my polynomial equation. And what I'm going to do is I'm going to plug it into my Desmos. And when I plug that into my Desmos, I get solutions at x equals 1 and x equals 3. Well, I know the 1 is not possible because there's a restriction there. So my x is equal to 3. And so in this case, my solution, and again, this is from my graph. Now, I suppose we could guess this solution and use the remainder theorem to do this, but being a power 6, we really should just get from the graph. X is equal to 3. Okay, or in this case, it should be R equals 3. So if R is equal to 3, we should answer the question here. It says, find the first three terms of the series. So I'm going to, first of all, I'm just going to solve for A. So I'm going to plug it into my first equation. A is equal to 121, and that's going to be R equals 3 minus 1 over 9 times 3 to the power 5 minus 1. So this ends up being 121 times 2. And in the denominator here, I get 9. 3 to the power 5 is going to work out to 343. Sorry, 243. Minus 1 is 242. And then we have common factors here. So a is equal to, it looks like this cancels out with this. So a is equal to 1 over 9. So we found 1 over 9. So the question asks for the first 3 terms of the series. So the first 3 terms are going to be 1 over 9. It's going to be the first 3 terms, this first term. It's going to be plus 3 over 9 plus 9 over 9. Okay, so S1 equals 1/9. S2 is equal to 4 over 9. And S3 is equal to 13 over 9. And I think that's in the general equation for the series. Then if I want to write the Sn for this, it'll be Sn equals 1 over 9, and then r to the power n minus 1 over 3 minus 1, and that simplifies to 3 to the power n minus 1 over 18. So there's my general Sn formula.